Okay, so this is going to be an analysis of the massive explosion that's just happened in by the docks in Beirut, which will, as you'll see, has obviously killed quite a lot of people, which is sad, and our feelings go out to them. But this is just going to be a straight analysis of what you can get out of the actual footage, as in what's the cause of this, how big was the explosion. So what we're actually looking at here is there is a burning building. This is the burning building down by the docks. There's little explosions going off inside of it, and then there is a large explosion which it rapidly obscures the. There's a condensation wave that rapidly obscures what's going on. The most important thing in judging the size of the fireball, in the size of the explosion, is that, which is basically the immediate size of the fireball. After that, you can get a rough estimate of the size of the explosion. Now, the first thing that this immediately reminds me of is the worst industrial disaster in American history, which was the Texas City disaster, where a ship carrying ammonium nitrate had caught fire, and loads of people gathered to watch the burning ship because it was kind of interesting. Thing is that ammonium nitrate is a tricky one. It's used by the thousands of tons for fertilizer, and most of the time, if it's a bit damp or loads of other reasons, it won't explode. It won't detonate. It'll just burn, which is what happened to the Grand Camp. But if you get past a tipping point, it detonates. So the whole thing basically goes up at about the speed of sound. So much less than a second, the whole thing goes boom. And in this case, the ship had 2,000 odd tons of ammonium nitrate on it, which is, it's just 2 kilotons. This is, bear in mind that the first nukes were only about 10 times this in size, 20 kilotons, and it absolutely killed 500 people, made a mess of the town, and all sorts. So this is the first thought as to there aren't many things where you can get thousands of tons of stuff that could explode in one place. Now, it turns out it's a semi-regular occurrence that if you get a where they make the ammonium nitrate, they will occasionally catch fire and explode. And this is one such ammonium nitrate plant burning. So, the burning looks kind of similar. The explosion looks quite different. And the smoke afterwards looks quite different. This is obviously a much, much smaller explosion. This is probably only a ton or so of explosives, or explosive yield. But the general format, you get the fireball, the blast wave comes off, and it's very red. This is a very different kind of explosion to the one that they just had in Beirut. Another one that it could be is some sort of military explosives, and for that you might compare it to, say, the Moab bomb. This is the mother of all bombs. It's a fuel air bomb, largest munition in that the US has, and it looks like it's nothing here, by the way. It's a massive bomb, and I forget what it is. It's like a 10-ton equivalent yield or something, but it's fuel air, so you don't expect any coloured smoke or anything, and there isn't any. It's just mostly water vapor, carbon dioxide, and some dust coming off here. So that red smoke is a real bizarre thing. So how big is this blast here? Well, you've got an estimate immediately. You've got a length scale here. You know, you can find this building on Google Maps, and you basically need to know the size of the fireball, and that'll immediately give you an estimate of how many tons of explosives equivalent that you're looking at. So if you come over to Google Maps, which I did earlier, you zoom out. This is Beirut. There you go, Beirut. And you zoom in, and it's this building here. That's the building in the foreground. So this is the building that blew up. They did look like it could have possibly been a ship, but yeah, if you look a bit closer, you'll see it's definitely this building that's on fire. So whatever was in that building is what exploded, and you can get an estimate of. There are two ways you can do it. The first one is you get the size of the fireball and you sort of convert that into the hot gases that you would get off a ton of TNT. Or another way, which is it's just easier in this case, is we know the size of this pier here, and this is about half the size of the pier. So we can. There is a website which allows you to. It's called Nuke Map. It allows you to detonate nuclear weapons of various sizes, and it gives you an idea of the damage that you'd be looking at. So the fireball radius is essentially what we were looking at. And this is about right for the fireball estimate in my reckoning, which equates to, can't quite see it here, it equates to a 1,000 ton yield. So just to give you some idea, if I turn this down to 0.1 kilotons, so that's 100 tons. I mean, it's this ballpark. It's somewhere between 100 tons and this would be 3 kilotons. So 3 kilotons is clearly too big. Probably it's getting on for a kiloton. This is a absolutely massive explosion. Certainly on a par for the Texas City disaster. And so there's the next question is, what the hell was it that actually exploded? Well, there aren't many things that you store by the thousand of tons that can explode. There's weapons. This doesn't quite look right for military weapons. For certain, if there are no military explosives that leave bright red. I mean, this looks like iron to me, honestly. Which thermite has actually no, thermite has iron oxide in it. But iron is just too heavy to put in military explosives, so unlikely. And the same goes for rocket fuel. It doesn't look right for ammonium nitrate, which sort of suggests, this could be a fireworks storage thing, which would certainly give you the maybe something to do with sulfur. I don't know. But whatever it is, it has to be. This is another thing. If it is fireworks, it's super difficult to get an explosion like this from just regular gunpowder, right? Because if you light regular gunpowder, it just sort of burns and goes thump. That's it. There's no real explosion that comes off of it. To get gunpowder to explode like this, you almost need it contained. So what you might be looking at is there was some sort of safe underground storage thing, essentially a magazine full of mixed firework powder. If these are just regular fireworks, you're not going to get an explosion like that. But if you had a large underground safe area, then quite conceivably Why on earth they would store 1,000 tons there, I'm not sure. But uh, you can't just get that sort of explosion out of regular fireworks, because the way that gunpowder explodes when it's really exploding is what causes the increase in the flame speed is the gases have to be confined. If the gases aren't confined with gunpowder, then it just burns regularly. However, if it's confined, then it's the hot gases move through the powder, and that's what advances the explosion front, which is very different from how things like ammonium nitrate detonate, which is one molecule falling apart actually causes the molecule next to it to fall apart. And that goes through all of your ammonium nitrate at the speed of sound. Very difficult to get that to happen with gunpowder. Gunpowder is a binary mixture. That looks like a real detonation. So, the only things that I can think of is it's a confined area with an awful lot of gunpowder in it. That would do it. Other than that, I just can't think of anything else that'll actually give you that color smoke. Anyway, so that's my analysis of that. Thanks for watching. And of course, our thoughts go out to the people in Beirut.